Hi everyone, this is the pre-class video for Monday, September 9th. This again is in Chapter 4. This is going to be a pretty brief one. We're just going to be talking about one particular aspect of statistical analysis that's really relevant to analytical chemistry, and it's one that we don't really have time to get to in a whole POGL, but I thought you guys should get some experience with it. It's called the Grubb's test for outlier removal, and it's Chapter 4-6. Okay, so once again, this is the Grubb's test from Chapter 4-6 in Harris. And, whoopsie daisy, what's going on here? Slideshow. And what happens, there we go. And so what the Grubb's test deals with is, as you remember, any one of our samples that we're looking at was just trying to get a representation of a population. And so the actual population may have a Gaussian distribution that looks something like this. But let's say if you take any 5 random samples, let's say your random samples end up here, 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 and here, there's a finite chance you get one that's outside of this normal distribution area. In fact, we generally define this area by about 95% of the population, so there's a 5% chance you're going to get a measurement that, let's say, is way out here. And so if the actual population looks like this, but your sample looks like this, the Gaussian that you would think that was just based off these 5 measurements may give you something completely different looking, like something like, let's say, that, right? And so you can see this is from your sample, from your sample set, and so you can see your sample set may give you a really unusually and not a representative approximation of your actual population. And so the question is, how do we deal with outliers such as this? And in practice, lots of times, what we'll find is in lab, if you take good notes, you'll find a reason, like let's say you're doing a titration and you accidentally missed some of your KHP from the vessel or something like that, or an air bubble passed through. That may be responsible for an outlier. But on other occasions, maybe you can't. It's not impossible for you to really determine what that outlier comes from. And so you need to use some sort of mathematical way to determine, is this actually an outlier that's really affecting your Gaussian? And that's where this Grubb's test comes in. So the Grubb's test, this is again from section 4.6 in your book. And so it's just this really simple calculation where you have your questionable value. So in this case, your questionable value would be this guy out here. And you subtract that, it's the absolute difference between that and the mean divided by the standard deviation. You get this thing called G-calc. And so just like what we've been seeing with the t-test, this is a statistical test. And so there's a table that you compare it against. And so in this case, if your G-calc is greater than your G-table, or your critical, or G-critical again, just like the t-test, you'll sometimes see this called the critical value. In this case, that means your questionable value is an outlier. And there's one important thing I want to note about this table, and that is a lot of your tests before, a lot of the t-tests and things like that, are dealing with degrees of freedom, and this does not. This is number of observations. Okay, so this is just n. It's not n-1 or anything like that. Okay. So we're going to run through a quick example and show you this in practice. And so this is from something I showed you before. This is both in terms of, and actually, I'm changing this value a little bit here. Whoops. This is, do that one, 0.51, I believe. All right. So this is a modified version of this example I gave you before, based on some data that you might see something like this, where you have a negative control and a exposed or a treated or something like that. And so we looked at this Gaussian before in our previous slides, and you saw you had these kind of funky looking distributions here, where you had right, here's your control, and here's your treated or your exposed, and we got this really broad, wide distribution for the treated. And so and if you recall even back further, when I was talking about confidence values, we showed you where these numbers came from. And so this is our confidence interval. All right, it's the confidence interval for this. This is for your treated your treated sample set, which gives you this really broad distribution. And if you look at the data where this comes from, you might find something suspicious. And so something you might find suspicious if you looked at it closely is this data point right here. See how these are also clumped around, 4.3, 4.1, maybe up to 5. And there's one right here, right, which is significantly higher. This one is almost 10, so it's almost double what the other ones are. So you see something like this, you might question and wonder, is this an outlier? And so this is where we want to apply the Grubb's test, right? And so the things you're going to want to know for the Grubb's test are your questionable value, in this case that's 9.95, your mean, your average, which is right here, 5.50, and your standard deviation. So this is a real simple calculation to do, which is 2.51. And so go through and calculate this. Let's change your color back. So gcalc is equal to a questionable value, which was 9.95, minus our mean value, which is 5.51, and you divide that by your standard deviation, which was 2.51. Okay, pretty simple calculation. You get 1.776. So now you need to compare your gcalc to your gtable. So what's your gtable? Gcritical. Okay, that's the same thing. If you look here, our number of observations in this case are 5. Okay. If you look at this table here, you look for your number of observations. There's 5. And you find a gcritical value of 1.672. Alright, so in this case we say gcalc greater than gcritical. Therefore, our value here, 9.95, is an outlier. And so if you're going to proceed with any sort of statistical tests, it doesn't really make sense to proceed with those. Like, let's say you were going to do a t-test, you'd want to remove that outlier. So just to sort of show you what kind of influence this can have with the outlier, your summary statistics are such that you have your mean is 5.51, and your standard deviation is 2.51, I believe. Keep forgetting that. And then without your outlier, let's say, you get a mean of 4.40 and the standard deviation of 0.4. Alright, okay, so as you can see, your values here decrease by a whole number here. It's about 20%, and your standard deviation, there's a huge difference in that standard deviation. So you can imagine if you remember your t-tests are dependent both on these mean values and your standard deviations, so that will be influenced pretty heavily by the presence of an outlier. So you want to make sure, if you have a data set where you see something that looks suspicious, like a data point like this that sticks out, you can run through the g-test to determine your gcalc, and if you see your gcalc is greater than your critical value, you can determine it's an outlier and remove it from the data set. Okay, so hopefully that was all clear for you guys, and again, that's on Harris, chapter 4.6. And I'll see you guys in class on Monday.